sessions. Today we are going to discuss about chemical equilibrium. Before entering into the lesson, we'll discuss about something. In our daily life, we can see number of changes. In that, some more changes we can see here. First of all, what happens if you take a ice in our hand? And again, what happens if you take a petrol in our hand? And what happens if we eat a stick? And finally, what happens if we eat calcium carbonate? We heat it. Here, if we heat the ice, it will turn into water phase. Well, if we take the petrol in our hand, it will turn into vapor. Well, if we heat the stick, it will get ash. And if we heat the calcium carbonate, we will get calcium oxide plus CO2 gas. Among these four, what you will observe? Do you think these four are equal? No. In the first two equations, we will observe only in the change in the state. They only change in the state. In the next two reactions, we will observe there is total complete change in their chemical composition. And all these together known as reactions. All these are together known as reactions. Mainly in reactions, we will observe two types of changes. One is physical and another one is chemical. In the physical change, we will observe there is only change in the shape and in color. Whereas in the chemical changes, we will observe entire change in their chemical composition and in matter present in it. And in this physical and chemical reaction, there are two types, mainly reactants which gives rise to product in these reactions, the reactions are completely turned into products, and these type of reactions are known as irreversible reactions. Perhaps let us suppose consider example 5. When we heat calcium carbonate, see KClO3, what we get? KCl plus O2. Then, and suppose in some more reactions, the reactants can give form products. Reactants can form products, whereas the products can give the reactants again back. The products can give even the reactants back. And these type of reactions are known as reversible reactions. Mainly these reversible reactions are occurred in the closed system. Whereas if we happens it in an open system, it will turn into a irreversible reaction. So we have to take these reactions in a closed region. Then example for these type of reactions are hydrogen plus iodine gives rise to hydrogen iodine. And in the decomposition of H2, we will get H and iodine and hydrogen back. In this reaction, firstly the hydrogen is colorless. The iodine has the color of violet, whereas the H2 is also colorless. When we start this reaction, we will observe a dark violet color in the iodine. Whereas when these two reactants are combined and form the product, the intensity of the violet color goes on decrease. And after some time, it will attain a constant value. Why it attains a constant value? Because the number of molecules transferring from reactants to products is equal to the number of molecules returning from products to reactants. and here comes the equilibrium. And today we are going to discuss about this equilibrium. Chemical equilibrium. Chemical equilibrium. Well, these chemical equilibriums are important in number of biological as well as in environmental processes. For example, the oxygen which is involved in the O2 molecules and the protein hemoglobin which is present in our blood plays an essential role in the transport and delivery of oxygen from our lungs to our muscles. Similarly, if you take any liquid in a closed container, after some time what you will observe, the liquid gets slightly evaporated. Why they are evaporated? Because the molecules of water possess higher kinetic energy and they transform from liquid phase to vapor phase. After when this evaporation is constant, here increases the pressure of vapor and it condenses and it comes down to water phase again. And it gives us a constant vapor pressure. These constant vapor pressure arises because there is an equilibrium between the number of molecules which is changing from water state to vapor phase is equal to the number of molecules returning from water state from the vapor state. Well, vapor state. We can consider this in a reaction. H2, firstly it is a liquid phase. Later when the reaction is happening, it converts into vapor phase. Right? And again, when the vapor phase, the intensity, the pressure increases, it again condenses to form liquid phase. And here at this stage, we can say that the system has this equilibrium. Well, why? Because we can say that the system has reached equilibrium because the rate of evaporation is equal to the rate of condensation. Here, rate of evaporation is equal to the rate of condensation. And what do you mean by these two half-headed arrows? These two arrows indicate that the reaction occurs in both the directions, both in forward direction as well as in reverse direction simultaneously. And the rate of the forward reaction is equal to the rate of the backward reaction. Well, then what is reaction mixture? The mixture of reactants and products in an equilibrium state is known as equilibrium mixture. Well, these equilibrium can be occur both in physical as well as in chemical processes also. Suppose when when some reactants are reacted together in a closed vessel and they form products, what you will observe? That the concentration, that means the concentration of the reactants goes on decrease. And here the concentration of the products goes on increase. At equilibrium state, they become constant. They don't change their concentration value. It does not increase and it does not decrease either. And this type of equilibrium is known as dynamic equilibrium. Dynamic equilibrium. In this dynamic equilibrium, both the rate of forward reactions is equal to the rate of backward reaction. Which means if the reaction in the reactants are formed products, then 5 moles of energy get converted into products, then 5 moles of products will get into reactants again. And this is dynamic equilibrium. And in dynamic equilibrium, there is no change in the concentration of reactants and products in an equilibrium state. Well, based on the extent to these reactions reach the state of chemical equilibrium, these are mainly 3 types. In some reactions, the reactions proceed almost to complete. We will think that the reaction has almost completed, but only a negligible part of the reactants are left. Reactants are left. And sometimes we cannot detect this experimentally. That means we cannot show it experimentally. We cannot show it by experiment. And in some more reactions, if you take 100% of the reactants, it forms only 1% of the product. And the 99% of the reactants remains unchanged at the equilibrium state. And this is another type of reaction. In some more reactors, the concentration of the reactants and products can be observable, which means they are comparable, which means they are almost equal. And here, the reactions are fast or they may be slow. It based upon the nature of the elements which we have taken and our environmental conditions such as pressure, temperature, and all. Well, in this chapter, we are going to discuss about number of important aspects about physical and chemical equilibrium. Firstly, let us come about physical equilibrium. Equilibrium in physical processes. In physical processes, equilibrium in physical processes we can easily understand by considering a small examples like phase transformation example. Phase transformation. Phase transformation. What is phase transformation? Phase transformation is nothing but changing from one state to another state. Right? Like from solid to liquid, liquid to gas, and again from solid to gas. First, let us take example for three reactions. Firstly, we will take in solid liquid equilibrium. How it will be solid liquid equilibrium? Solid liquid equilibrium. Let us place, firstly coming to this, what will happen when we take some ice cubes in a bowl, it will evaporate and it will get condensed into water. For this reason, we will take some ice cubes and water in an insulated thermos flask, which means the heat which is present inside the flask should not enter outside, and the heat which is present in the surroundings should not enter inside, right? Let us consider this is an insulated thermal flask, and let us place some water and ice cubes in it. Let us place some ice cubes in it. After some time, what you will observe? At a particular temperature, what is the temperature? 223 degrees Kelvin temperature and at 1 atmospheric pressure. We'll conduct this experiment. These experiments show very interesting factors, which means the mass of the ice cube and water does not change with time. Whatever the time, the mass of the ice cube and water remains constant. However, there is an equilibrium between the ice cubes and water. How it will be? When these liquid molecules get collide, that means they hit against the ice cubes and they attach to the ice cubes and they transform into solid state. And here, the ice cubes, they start condensing and they transform into liquid state. Thus, there is an equilibrium between the ice cube and the water molecule, which means the number of molecules returning to solid state is equal to the number of molecules coming from solid state to liquid state. Here, there are equilibrium between the solid cube at particular temperature, at 223 degrees Kelvin temperature and at 1 atmospheric temperature. And what is melting point? Normal melting point. If normal boiling point. If two reactants, if we take any reactant, the temperature which the solid and liquid state at the equilibrium is known as normal melting point or normal freezing point. Here, normal melting point or normal freezing point are something. Here, the experiment is dynamic in nature. How we can know this is dynamic nature? by two regions we can know it is dynamic in India, in which the rates of forward and reverse reactions are equal, and both the rate of the reaction is also equal. That means the mass of the ice and water do not change, so that this is a dynamic equilibrium. Well, again, coming to the liquid gas equilibrium, liquid gas equilibrium. For this experiment, we will consider a transparent box. Transparent means nothing but a glassy substance, which means you can see from one side to another side. And with the transparent box, which containing a tube, U-shaped tube, nothing but manometer with mercury. And in this reaction, we know drying agents like dihydrous calcium chloride, or otherwise we can take phosphorus pentoxide. Let us keep these drying agents in a bowl and place it in a transparent box. After some and place it for a few hours. After some time, remove these drying agents from the box and place a water in a petri dish, means a bowl. Place a water in the box. What you will observe, the pressure inside the box increases, so that the level of mercury also increases and attains a constant value. Which after some time. Why the mercury level increases? Because, and you can also observe the water level in the dish also decreases. Why this mercury level increases and the water level decreases? Because the liquid molecules get transferred into the vapor phase, and here increases the pressure, so that the mercury level increases in the right limb of the manometer. And here there is an equilibrium between the vapor state and the water molecules. And here the rate of evaporation is constant. However, the rate of pressure decreases with time due to the condensation of vapor molecules into liquid phase again. And here arises an equilibrium. And if we repeat these experiments with methyl alcohol, acetylene and ether with different volumes of liquids, we will observe different liquids have different vapor pressures. What is vapor pressure? At equilibrium condition, the pressure which is extracted by the water molecules at a given temperature is constant, and that is known as vapor pressure of the water or equilibrium vapor pressure of the water. These vapor pressure increases with increasing temperature. And if we observe these experiments with methyl alcohol, acetylene and ether, we will observe that different liquids have different vapor pressures, which means one liquid can evaporate easily and one more liquid can evaporate slowly. And the liquid which has higher vapor pressure is more volatile, which means easily evaporated and has lower boiling point. The liquid has lower boiling point. And let us consider one more example. Let us take 1 ml of acetylene or ether or water in a bowl, 1 ml of bowl, and we will place it in a warmer room. What you will observe? You will observe that the water in the liquid at different volumes you have to take. Like the water in the liquid which is present in the bowl gets completely evaporated. These completely evaporated because the conditions are temperature. Because it depends. This evaporation may occur because of this. Because it depends upon the nature of the product, which means here if it is a volatile product, it can evaporate very easily. And here the amount of liquid amount means if you take a little bit of limit, it will evaporate easily. Within a short time, it will evaporate. And one more thing, and temperature. If you increase the temperature, automatically the boiling point increases and it constant and it evaporates easily. And finally, when coming to these solid gas equilibrium, solid and gas equilibrium. And here, the process in which the solids turn into direct gas process is known as sublimation process. Let us place some solid iodine piece in a closed vessel. After some time, what will happen? We will observe intense violet color in the vessel. A violet color, a dark violet color we will observe in the closed vessel. After some time, what will happen? The intensity of color remains constant. We think that the reaction has stopped, but it never stops. It goes on continuing. Here increases the violet color vapor, which means this solid iodine gets converted into the vapor phase, and here the pressure, when its pressure increases, it again condenses and forms this solid iodine. Here forms an equilibrium between the iodine solid and iodine vapor. Right, firstly it is at solid state. Later it is converted into gaseous state. Right? And there is some more reactions in the picture there. That is dissolution of solids in liquids. Solids or gases in liquids. Dissolution of solids and gases in liquids. Solids and gases in liquids. Firstly, we will observe, with our experience we can know, we can only dissolve a limited amount of salt or sugar in a given solid. Let us consider, I will show you an example. Here, we have taken some water in this. And what will happen if you dissolve a limited amount of sugar? It will dissolve in it, right? It will dissolve in it. What will happen? It will dissolve. It will get dissolved. And after some time, if you add some more solid to this, what will observe? We will observe some of the solid particles dissolve at the bottom, and some more solid particles get dissolved in this water. And here there is an equilibrium between the solid molecules which is dissolved in the liquid and the solid molecules which is present at the bottom. And these type of solutions are known as saturated solutions. Here, saturated solutions. And here, how can we know this is a dynamic nature? By knowing these rates of reactions, we can also know the dynamic nature by adding radioactive sugar. Firstly, we are discussing about solid liquid. Solids dissolve in liquids. This can be known as solids in liquids. And there, when these arises, solids in liquids, here forms the saturated solutions. And to know the dynamic nature of these solutions, these equilibrium, we will add some radioactive sugar to this non-radioactive sugar. What will happen if we add a few drops of radioactive sugar? What will observe? The radioactivity is observed both in the solid sugar and the sugar which is dissolved in the solution. Firstly, there was no sugar radioactivity in the solution. but we are arranging the dynamic equilibrium between the solid sugar and the sugar which is dissolved in the water, so that there is an equilibrium between the solid sugar molecules and the liquid sugar molecules and the liquid sugar molecules. And again, let us come to gases and liquids. Dissolution of gases in liquids. What happens if you open a bottle cap of a soda bottle? You will hear some sound, like sound will hear. These sound arises because the phenomenon of the solubility of carbon dioxide in the water at different temperatures. And this can be gauged by Henry's law. What is Henry's law? Henry's law said that when you take the mass of a gas dissolved in a given mass of a solvent at any temperature, it is directly proportional to the pressure of the gas over the liquid. It means the pressure which is this sound arises because the pressure on the carbon dioxide on the liquid. And if let us suppose consider if there is a 5 atmospheric pressure in the bottle, and outside we will observe 1 atmospheric pressure. If you open the bottle, what you will observe? The gas comes down, the gas goes to the surroundings, and it forms a equilibrium and resets. And here, let us go to the chemical equilibrium. Equilibrium in chemical processes and dynamic equilibrium. Same as physical processes, chemical processes also show dynamic equilibrium. In the chemical substances, the rates at which the reactant gives products here the reactants are converted into products. Here the rate of forward reaction is equal to the rate of backward reaction, right? And here, after the equilibrium is attained, there is no change in the concentration of either reactants or products, and this is known as chemical equilibrium. This can be easily understood by considering a simple example. Let us take A and B as a reactant and C and D as a product. And here is the graph. Firstly, when the at the initial stage, the concentration of the reactants are 100%, and the concentration of the product at 0%. And this can be shown by a graph. This can be shown by a graph. Firstly, you can see the reactants have a concentration of 100%, and later, and the product of concentration 0%. When the time is happening, the concentration of the reactant goes on decrease like this. The concentration of the reactant goes on decrease, right? And the concentration of the product goes on increase. Concentration of the product goes on increase. After some time, they attain a constant value and they go in a straight line, which means at this stage we can say that the system has this equilibrium. This is one type of chemical equilibrium. And one more. Here we are knowing about the concentration, and what about the rate in which rate the forward and backward reactions are happening. In this, here the same, the concentration at starting point is 100 of the reactants, and the concentration of the products are 0 point. When the time consuming, the concentration of the reactants goes on decrease and the time is later. And the concentration of the products decrease